All right, so we're going to go a little deeper now into signal transduction or cell communication. Remember, we went through just kind of the basics of cell communication. Now we're going to go in to get a little more detailed on how this happens. And remember, always look up here. So how do cells communicate? By generating, transmitting, receiving, and responding to chemical signals. Pretty good. It uses what's called signal transduction. Now, everybody, if you've ever watched dominoes fall, one will fall, and then we'll hit another one, and then we'll cause that one to fall. And I want you to think about this all the way through. Now, remember, if you get confused or it starts sounding like really crazy, go back to what I taught you. Go back to knowing there's a signal, then there's a target, and then there's a response that's created. So whenever you get confused, go back to that, and then it should kind of help you get set straight. So let's go into signal transduction here a little bit. And so here is just a kind of a generic signal transduction pathway. You're going to have the signal, you're going to have the target, which is called reception, and then it's going to be transduced under here, transduced under. That means when you receive transduction, that means it's moved across. So the signal is being moved across the membrane that it normally can't get. The signal here can't get across because either that molecule is either too big or it's too polar. And so Mother Nature has figured out a way that it can actually send this across the membrane without this having to go through. And so you have your signal, your target, and then the process of moving across the membrane is called transduction, and then some other things go on in there, and then you have your cellular response. Now remember, keep in mind, this signal is very, very specific to the response. This one signal is not going to create multiple responses here. Okay, so if up here are your steps: reception, transduction, and response. So here and here and down there. And so let's look at them a little more. So in reception, that's just that detection of that signal molecule that originates from outside the cell. Okay, the next step is that signal is going to be converted to a form that the cell can actually use. Remember, this signal cannot get across the membrane, and so Mother Nature has figured out a way to use that target protein on the surface of the cell to convert the signal that will eventually lead to a response from the cell. And then the response, remember, it's very specific to whatever cell action, to what's called the ligand. Now, the ligand is just simply that signal molecule. This would be the ligand, okay? And it's very specific. You think about enzymes and substrates. Remember, one enzyme only works on one substrate, and then it breaks it up. Same thing here. One cell target protein is only going to work with one particular ligand or one signal, okay? And then it's going to create that response. So again, look at the ligand. If I give you a biology definition, it's a small molecule that fits inside a larger molecule. And if you look, knowing that, there it is. You got a small molecule fitting into a larger molecule. Now, sometimes the ligands are mostly hormones or proteins, things of that nature, but they can be ions, like calcium. Calcium I'm going to show you here, but generally just small chemicals, and normally they're proteins, but sometimes they could be charged ions. And again, very specific. And so if you look at this example, here you have this transmembrane protein that goes all the way through the cell membrane, and then you have your ligand, your small molecule that's going to fit inside here. And what it does, it's going to create what we call a conformational change. So once it locks in, it's going to force this to change its shape, and then that's going to allow these light blue calcium ions to stream through. That is exactly kind of what we're talking about here. but in this case, this is called a ligand-gated ion channel. And there's your ligand, and it's a gated, and so it's a gate that can be open or closed, and then it creates a channel for the calcium to go through. This is kind of how our muscles work, calcium influx and then sodium outgo, and reverses it. So that's an example. Okay, and then here you have your ligand, and this is step 2. This is the reception. Your ligand, remember, this is a small molecule that fits into a bigger molecule, and so when that ligand comes in and it binds, it's going to make the protein that goes all the way across, it's going to make it change, and then that's going to set off that relay race, or that domino fall that is going to take place. Now, once the reception, it's going to send the signal, and it has by making this conformational change here. That's called transduction. Now, this ligand is what's called, and probably be good to know, this generally is called the first messenger. Okay, and if you ever see that, then you know automatically there's probably going to be a secondary messenger, and I'm going to show you that here quick. Now, since we're not in AP, we don't really have to go super deep, but we do need to know what that secondary messenger is. Okay, and so here it is. It's called CAMP or CAMP, cyclic AMP, and it's always a secondary messenger. And you can see, if you look at the diagram, here's your first messenger, your ligand, the hormone, and it's sending the message. It's being transducted through the cell, and then here's that domino fall, and then cyclic AMP is created, and then that creates a cascade of the signal. Now think of a waterfall when it's falling. It falls into, if you watch a waterfall just doesn't fall straight down into a nice perfect column. It cascades out. And so this cascade effect, what this is going to do, this is going to make that signal stronger. It's going to amplify it. So it's kind of like you're turning up the volume for music. And this is that cascade created by this secondary messenger. Another cool way to think about this is one language, and it's going to be changed over to a totally different language. So it's kind of like a translator. If you say this is English and this could be Spanish, and it's going to change it into that language that the cell understands, and that can get a result, get that response going. Okay, so remember, secondary messenger, and it amplifies the signal. Okay, and there's the signal cascade that I was talking about. It just relays the signal from the receptor to the targets in the cell, amplifies it, and then it creates the response. Now, last thing. Many of the cell responses that we use this signal transduction pathway is cell growth, right? That might be a signal to make your cells grow and divide, and then turns genes on and off. This could be in a situation where mice that live on dark rock, they need dark fur, and so the signal will turn on the genes or turn the genes off to give them light or dark fur, relying on wherever their environment is, and then the secretion of molecules. Okay, and so this would be maybe like adrenaline. So you get startled or scared, or watching a scary movie, epinephrine starts this. That would be your signal molecule, and it releases adrenaline to heighten your awareness and make you stronger, make you faster, ready to react.